So it is LC oscillatory circuit. Okay. The application point of view, it's a very huge area. In fact, any oscillatory circuits in with communication system, it will have basically this system. So basically consists of a capacitor and a inductor. Now what I am doing is initially I'm charging this capacitor, say by V volts. The capacitance of the capacitor is C and the inductance is of value L. Right. Now what I am going to do is I'll close the key. When I close the key, at any instant, let us assume that the charge here is plus Q, minus Q. And at that instant, say the current is I. If you ask me what is current in this case, I will say minus dq by dt. Equation 1. Any doubts in this part? Students, do you have any doubt? Why I have written I as minus dq by dt? Because charge is decreasing there. And also, at any instant, the drop across the capacitor is L di by dt, equation 2. Now, see, di by dt, now use 1 into. We will get Q by C is minus L d square Q by dt square, which in turn I can write it as d square Q by dt square plus Q by LC is equal to 0. D square Q by dt square plus omega square Q is equal to 0. This is in this form. So with this I can conclude, wherever you have omega, I can write it as 1 by LC. Now what is this? This is an equation for an oscillator. This is the equation of an oscillator. So from this what I can conclude is that you can write Q as Q cos omega t, where Q is the initial charge at t is equal to 0. And the current is given as a minus dq by dt, which you can write it as omega q sin omega t. And remember, omega q is called maximum current, sin omega t. So your charge is oscillating, current is also oscillating. So if I plot some graph, x-axis, y-axis, y-dash axis. In this, Right. That's how you will have the graph. Remember, the red line part indicates the charge as a function of time. This is at t by 4. This is at 3t by 4. This is at t by 2, and obviously this is at t. If you follow the current graph, the current graph is like this. Like this. The blue color line represents current graph, I graph. So when the charge is zero, the current is maximum. Okay, mathematics says this. What is actually happening here? Let us try to study. Initially, at t is equal to 0, initially when you have charge plus q and minus q here, the entire energy is energy stored in the capacitor as a form of electric field energy. And there is no current. This is at t is equal to 0. Now what is happening at t is equal to at t is equal to t by 4, what is happening is the total energy is 0. There is no field here, no charge. But current reaches a maximum value. And in fact, the entire energy is in the form of magnetic field. And again, thereafter, what is happening? Almost the current becomes 0, and the charge positions in the capacitor gets reversed. Now you see the electric field is in this direction. Now again, the entire energy is stored in the form of electric field. Remember, this is at t is equal to t by 2. And again, what happens thereafter? This is in half cycle. What is happening in half cycle, I have shown you. Thereafter, what happens? Again, the current becomes a maximum in opposite direction. And the charge becomes 0 here. And the entire energy is again magnetic field form magnetic field form. And remember, this happens at T is equal to 3T by 4. And again, you will reach the condition same as the initial condition, and the total electric field restored at T is equal to T. This is what happening in one cycle. In fact, electric field oscillates between the plates of the capacitor. Magnetic field oscillates inside the inductor. Current oscillates, charge oscillates. So that is the reason why it is called LC oscillatory circuit. So now, to be honest, at any instant, what is the total energy? At any instant, total energy is Q square by C plus half Li square. Yesterday, I have shown you work done in an inductor is stored in a form of magnetic field given by half Li square. Remember, this can be given as Q square by 2C, or this can be written as half Li maximum square. It is up to you. This is the fundamental of LC oscillatory circuit. Now I am asking you again, entire thing is in one picture. Now tell me, do you have any doubt on this? Boys and girls, do you have any doubt? Now you see, I can see only 12 students. Out of 12, 2 are from my entries. Only 10 students are there. You people expect extraordinary performance again. Palvita, have you understood? Mahant, have you understood?
Yes, sir.
Geetika, have you understood?
Yes.
Now tomorrow I am going to apply on this actually. Higher end problems. Someone raised their hand. Someone raised hand. I didn't. It's from my end, but I didn't do that. Okay, no issues. Right. So now we'll apply this. We'll apply on this. In an LC circuit shown in the figure, the switch is closed at T is equal to 0. The switch is closed at T is equal to 0. Q max, maximum charge is 100 microcoulomb. L given, C given. Or what is the expression for omega? 1 by root LC. 1 by root LC. 1 by under root L refers to 40. 40 into 10 power minus 3 into 100 into 10 power minus 6. And that works around 1 by 2 into 1000. This is 500 radian per second. Equation for instantaneous charge on the capacitor. Just now I have given everything. Q is Q cos omega t. Current I is I max sin omega t. What is I max? I max is omega q. Omega represents 500 and this is 100 10 power minus 6 amps. So this is 50 milliamps maximum current. So that's all. I've done everything. Any doubt here? What to ask a doubt? It's a simple question actually. It's a very simple question, honestly. But still open to you. You have any doubts? Please ask me. Any doubt? Geetika, do you have any doubt?
No, sir.
Right. Right. And Soumya, వింటున్నావా? Palvita, have you understood?
Yes, sir.
Right. See, all the time be alert. I don't know when I will question you. Initially, the question is here. Initially, the 900 microfarad capacitor is charged to 100 volt, and the 100 microfarad capacitor is uncharged in the figure. Now, switch S2 is closed for time t1, after which it is open. Remember, what is the charge initially? Remember, initially this right hand part here is LC oscillatory circuit. Okay, now you take only this part for a while. Inductor like this. Remember, this is a 900 microfarad and this is a 10 Henry. For this circuit, what is going to be omega? Omega is 1 by root LC, which implies 1 by root L. L means 10. Capacitor 900. 900 into 10 power minus 6. So this will become 9 into 10 power 900 into 10 covered, and this will become L is 10. This is 900. 9 into 10 power minus 3. This is like under root 1000 by 3. That is omega. For that part, right. Now we enter into the question. Then switch S2 is closed for time t1, after which it is opened, and the same instance which S1 is closed for time t2 and then opened. Just stay. It is now found that 100 microfarad is charged to 300 volts. This is an important observation. It is found that 100 microfarad capacitor is charged to 300 volts. Find the minimum possible values of the time intervals T1 and T2. May I ask you one question? What is the maximum voltage of this one? What could be the maximum energy stored in this one? Okay, hold on. This is omega 1, and the time period in the first part is 2 pi by omega, which is 6 pi by 10 root 10. Keep this aside. Now you speak about the other part. You take about the other part. For the other part, this is 10 Henry and this is 100 microfarad. So for this omega 2 is, let this be L1C LC1, sorry, and now it is LC2. So which is nothing but 10 into C2, 100 into 10 power minus 6, root 1000 by 1. T2 is 2 pi area by 10 root 10. Because 1000 can be written as 10 root 10. Right? I'm very clear on this. Right. Now, see, try to please understand in this process, what could be the maximum energy transfer? Because see, please try to understand, I need to check one point. What is that point? I'll try to explain you. There is a cross-checking situation. It's a cross-checking like kind of situation. The maximum energy stored is half into well, suppose the entire energy, whatever stored in 900 microfarad, C1 V1 square is, suppose if transferred to this one, it's a rough calculation I'm doing. Cancel. C1 is 900 V1 square and it is 100 V2 square. Wow, 9 times V2. 3V1. V1, you said 300 volts. In that case, this will become 300. Got the point. I have done the question. I hope you got the point. You know what I am going to do? Yes, now I'll follow. 0 to T1 by 4 seconds. Total half C1 V1 square is stored in 10 Henry inductor. Agreed? అరే మీరు ఎవరో ఒకళ్ళు ఎస్ఓ నో చెప్పకపోతే వింటున్నారో లేదో కూడా తెలియదురా. అరే నువ్వు చెప్పరా నాకు, గీతిక మహంత్ అట్లీస్ట్ ఆదిత్య నువ్వు మంచి స్టూడెంట్, నాకు చెప్తూ ఉండండి. ఎస్ అని చెప్తూ ఉంటే మీరు వింటున్నారని అర్థం అవుతుంది నాకు. అదర్వైజ్ మీరు వింటున్నారో లేదో నాకు ఎలా తెలుస్తుంది? ఇక్కడ దాకా క్లియర్ అయినారా ఆదిత్య? 0 to T1
Yes, sir.
ఇంత ఎనర్జీ స్టోర్ అయి ఉంటుంది, కరెక్టేగా? ఇప్పుడు
Yes, sir.
ఎనర్జీ స్టోర్ అయింది మళ్ళా, అంటే ఈ టీ ఈజ్ ఈక్వల్ టు 0 అప్పుడు ఇది, T1 అంటే ఇప్పుడు ఇది. నెక్స్ట్ ఎంత అవుతుందో తెలుసా? మళ్ళా నెక్స్ట్ సర్క్యూట్కి T1 T2 by 4 అప్పుడు ఏమవుతుంది? హాఫ్ C2 V2 స్క్వేర్ ఈజ్ స్టోర్డ్ ఇన్ C2. ఇప్పుడు మీరు అడుగుతున్నది మినిమం పాసిబుల్ వాల్యూస్ ఆఫ్ T1 కదా. T1 వచ్చేసి 1/4 ఆఫ్ T1. 1/4 ఆఫ్ T1 ఏం రాస్తారు? 6 pi by 10 root 10. 2 times, 3 times. 3 pi by 20 root 10. అది ఎంత అయితే అంత నాకు అనవసరం. T2. See, T2 is closed for time T1, after which it is open, and the same instant as for time T2 and then open. అంటే ఇక్కడ T2ని ఎట్లా కౌంట్ చేయాలో తెలుసా మీకు? T1 ప్లస్ T2 by 4 అంటే 3 pi by 20 root 10 plus 1/4 of this. 1/4 of this అంటే 2 pi by 40 root 10 అంటే pi by 20 root 10. అంటే ఇది you will get this as 4 pi by 20 root 10. అరే, that you can manage. Honestly tell me, have you understood or not? Where went my logic? Since it followed this logic, I'm very comfortable. Otherwise, n number of options you will get. N number of options. which is very difficult for us to determine. Huge mathematics is required. Very fortunate that it happened for me. Aditya, are we clear?
సార్ ఒకసారి లాస్ట్ స్టెప్ చెప్తారా సార్ T2 ఈజ్ ఈక్వల్ టు T1 ప్లస్
అదే
T2 బై
నువ్వు
4.
ఆ T1 ఎక్కడి నుంచి లెక్కేసావు అనేది ఇంపార్టెంట్ కదా. ఇప్పుడు 0 to T1 లెక్కేసావు, T2 ఎక్కడి నుంచి లెక్కేసావు? If T2 is counted from S2 opening point to S1 closing point, then T2 becomes T2 by 4. But I don't think there is a situation like that. You are counting right from T is equal to 0 onwards. You are counting everything from T is equal to 0. And the moment when you started closing S2 with S1 being opened, అక్కడి నుంచి లెక్కేసావు కాబట్టి T2 ఇంటర్వెల్ టోటల్ టైమా అక్కడ క్లారిటీ లేదు. నేను టోటల్ టైం తీసుకున్నా. ఇంటర్వెల్ అయితే అసలు ఏమీ లేదు ఆన్సర్స్. T1/4, T2/4. But I don't think second part is an interval. It is a total count from that time to this time. Any doubt, Mahant?
ఓకే
Right.
సార్ అది ఇప్పుడు టోటల్ లేదా ఇంటర్వెల్ అని చెప్పేసి ఎట్లా తీసుకుంటారు సార్ అది T2?
యాక్చువల్గా నాకు కూడా కరెక్ట్గా ఐడియా లేదు. మినిమం అక్కడ వాడు నేను ఇక్కడ ఎలా తీసుకున్నట్టే S1 ఈజ్ క్లోజ్డ్ ఫర్ టైం T2 అన్నాడు కాబట్టి నేను అలా తీసుకున్నా. అంటే కొంచెం క్లారిటీ ఇస్తాడు మీకు క్వశ్చన్స్లో.
సరే సార్.
ఐఐటిలో క్లారిటీ వస్తుంది మీకు. ఎస్, someone was trying to reach me. Mahant, any doubt? Right.
నో సార్.
ఈ క్వశ్చన్ ఈజీయే. I don't want to do this question. Yes. Okay. Try this. Some questions we will do tomorrow. ఇది కూడా ట్రై చేయండి. ఇది కూడా అలాంటి క్వశ్చనే అనుకుంటారా? ఇది కూడా అలాంటి క్వశ్చనే. యూ ట్రై దిస్, నో ఇష్యూస్. ఫండమెంటల్ మోడల్స్ ఫస్ట్ చేయాలి. సూపర్ క్వశ్చన్. ఇట్స్ అన్ ఎక్సలెంట్ క్వశ్చన్. ట్రై దిస్, ఎవ్రీవన్ ట్రై దిస్. Remember fundamental rules. When the inductor with thumb rules, please. When the current through the inductor is maximum, the thumb rule is potential drop across the ends will be 0. That is a thumb rule. Please remember this. When the charge across the capacitor is maximum, when Q reaches a maximum, current will be 0. These are the two fundamental rules that you need to know to solve this question. Your time starts now. Go ahead. Start working on this immediately. Two capacitors of capacitance C and 3C, you can see that, are charged to a potential difference of V0 and 2V0 respectively and connected to an inductor of inductance L as shown in the figure. Initially, the current in the conductor is 0. Now switch is closed. The maximum current in the inductor is, please try to understand, when the inductor reaches maximum current state. When the inductor reaches maximum current state, Inductor behaves like a conductor. When you have maximum current. Boys and girls, this is the sentiment step. Geetika, any doubt? When the current through the
No, sir.
inductor, I have removed inductor with a conductor, which means now there is no potential difference, which means the common potential. No, see, very simple. I am assuming that some charge may to be transferred during this time. Some charge might be transferred. Earlier, it has a charge CV naught, now CV naught minus Q here. Earlier, it has 6 CV naught, now the charge is 6 CV naught minus Q. You said the potential drop across this is 0. Honestly, you should accept every step here. Otherwise, it is your right to question me. CV naught minus Q by C plus 6 CV naught minus Q by 3C is equal to 0. Yeah, of course, you said, man, potential drop is 0. So therefore, any doubt in this step, by the way, Geetika, Mahant,
No,
Aditya?
sir.
No, sir.
No,
No,
sir.
sir.
Right.
No, sir.
V naught minus Q by C plus 2V naught minus Q by 3C is equal to 0. 3V naught is equal to 4Q by 3C, which implies the charge transferred is 9 CV naught by 4. That's the charge transferred across. Potential difference across the capacitor of capacitance C across this. Let that be V1. V1 is now CV naught minus Q by C. CV naught minus 9 by 4 CV naught by C, which implies minus 5 by 4 V naught. So that is the potential drop. So 3 array, but don't question me minus or plus ani. Okay, అది నువ్వేం చెప్పలేదుగా points. A across, see, suppose if this is A and this is B, VA minus VB is this one. What is VB minus VA? 5 by 4 V naught, right? And what about the other? Let this be C. VB minus VC is, what is VB minus VC? Ariyar, VA minus VC 0 kavali. What is this? Plus 5 by 4 V naught. No calculation required. Across C. Across 2C. So, by the way, how to find the maximum current in the inductor? How to find? Okay, no issues. See, please try to understand one point here. Just please try to understand. Even now, you can still use IMAX. No. I will do it in a professional way. Thereafter, I will tell you shortcut. Okay, right. I apply Kirchhoff law, LdI by dt. LdI by dt is what? At any instant, CV naught minus Q by C plus 6 CV naught minus Q by 3C. By the way, what is this going to be? 7V naught minus Q by C minus Q by 3C minus 4Q by 3C. This is the professional way of doing at any instant. This you can apply at any instant. At any instant you can use this. Now when current is maximum, I is maximum, di by dt is 0. Means the Q becomes how much? Just please confirm whether my steps are correct or not. I think somewhere I went wrong. V0 plus 2V0. This is a 3V0. 3V0. So therefore Q becomes 9CV0 by 4 RR. What else I have derived here? Yeah? What else I have derived? It's the same. So when this much charge is transferred, current is maximum. So therefore, you can write simply maximum current is omega times the charge transferred. That is the maximum charge that could be transferred. Yeah, in the original case, total Q will be transferred. Here, this is the maximum charge transferred. Now tell me what is omega. Omega is 1 by root L C effective times 9 CV0 by 4. Hold on. What is the C effective here? Please help me in writing C effective. It is that you can do. It is that you can do. C effective. Yeah, help me. What is C effective here? C effective is nothing but series combination of two capacitors. C 3C series by 4C. This is a 3 by 4C. So therefore, this can be written as root 4 by 3LC times 9CV0 by 4. Remember, that is the maximum current. We need to adjust this properly. How to adjust this properly? You can write, this one becomes 3. This one becomes 3. We will write everything into the root. That gives us clarity. 3LC 9CV0 by 4 can be written as 81 C square V0 square by 16. 16. You can write this as 27. 27 means 9 threes are 27. CC cancel. Hold on. 9 threes, 3 V0 by 2 I can take common out. And what is left inside? What is left inside is 3C and L. I have brought everything out. So what is that 3V0 by 2 by root 3C by L? Absolutely correct. So what I have done for maximum current, please tell me in such situations. Imax is omega times maximum charge transferred. This is the fundamental rule. But by applying this rule, I have followed these terminologies. When current is maximum, potential difference across the inductor is 0. When charge is maximum, current through the battery, current through the capacitor is 0. Right? Yes, boys and girls. Now please ask me if you have any doubt in any of my process. Please ask me comfortably. Repeated model in our system, a very repeated model. So I have done in one shot everything. Please ask me if you still have doubt, please ask me. If you are not convinced, I think some students are not convinced, no issues. I will do it traditionally also, traditionally. So I can write L d square q by dt square is equal to 3v naught minus 4q by c. Okay, now this you write it as d square q by dt square is equal to 3v naught by L minus 4 by LC times Q. I think I need to set this into our standard form, For this purpose, I will define a term called Z. So what is Z? I am taking Z as 3v naught by L minus 4 by LC times Q. So what is dz? 0 minus 4 by LC dq. So now I got everything. If you are using this, let it be this. Now d square z by dt square can be written as minus 4 by LC. Just please confirm whether it is a true or not. Just 4q. Somewhere I went 4q by 3 CR. You are not helping me these days. 4q by 3LC. 4q by 3LC. 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 D square q by dt square. Now, after doing all such markups, now this will become what? You can write this simply as minus 3LC by 4 d square z by dt square is equal to z. You can write this as d square z by dt square plus 4 by 3 LC times z is equal to 0, which means omega is root 4 by 3 LC. That's omega. I got same omega we got. Same omega we got. Dekho, omega same term we got. And number 2, equation writing. Z is Z max times some sine. I'm assuming like this, sine omega t plus phi. I'm assuming like this. Right. Now in this case, 3v naught by L minus 4 by 3 LC into Q is Z max times. I'm just a trial solution, this one. No idea, so trial solution. Put t is equal to 0. When t is equal to 0, q is equal to 0. Z becomes 3v naught by L. So therefore, 3v naught by L minus 0 is equal to Z max cos sine phi. But that is not sufficient. That is not sufficient. So because two unknowns are there for me. What else I need to try? I told you I'm doing in a traditional way, a lengthy way. Because at some point of time, someone looked to me that, you are cheating us. How do you do this all? That is the reason why I am telling I'm not going to derive this. I am going to differentiate this. dz by dt is omega z max cos omega t plus phi. But I know dz by dt, which is nothing but minus 4 by 3 LC dq by dt is equal to omega z max cos omega t plus phi. ఆదిత్య ఇక్కడ దాకా ఏమైనా డౌట్ ఉందా? జస్ట్ నేను ఒక స్టెప్ తర్వాత ఒక స్టెప్ వేసుకుంటూ వెళ్తాను. టిల్ దిస్ పాయింట్
No, sir, no doubt.
రైట్. నాకు ఒక విషయం చెప్పు. ఎట్ t is equal to 0, కరెంట్ జీరోనేగా. కరెంట్ మాక్సిమం t/4 seconds తర్వాత అవుతుంది. Initially current is 0. The entire term is 0, which means 0 is omega z max cos phi, which clearly implies this is a non-zero term. The entire 0 is because of cos phi. So phi is equal to pi by 2. So which means I have understood the equation properly now. The equation is 3V naught by L minus 4 by 3 LCQ is Z max times sin omega t. Right. Good. So I have done, I got the equation. But by the way, what is Z max? That also I require. No? Hold on. What is going to be the Z max? So which is nothing but 4 by 3 LC is equal to 3V naught by L minus Z max sin omega t. So Q is 9 CV naught by 4 minus 9 CV naught by 4 minus 3 LC by 4 Z max sin omega t. This is the expression for Q. Right. Now again put T is equal to 0. No, hold on. This is the charge transferred actually. 3LC by, this is the charge transferred. Now, very clear, put T is equal to 0, 9 CV naught by 4. Right. So, 5 minutes, sir, almost. 9 CV naught by 4. Now, you come back to here again. When will be Z maximum? What is Z maximum? When is this one 0, that time it is Z maximum. When this time Q is equal to 0, so Z maximum is 3B naught by L. So that is 9 CV naught by 4 minus 3 by 4 LC. What is Z max? You said from here. Z max is 3V naught by L. 3V naught by L sin omega t. LL cancel. So 9 CV naught by 4 into 1 minus sin omega t. Right. This is the Q value. In fact, this is the charge transferred. So the maximum value of this is what you need to find. Instead of doing all this, trust me, use only one maximum charge transferred into omega. Why? Because see, if you want dq by dt, what you will get? 9 CV naught by 4, 0. Sin omega t becomes cos omega t. Omega means omega, somewhere I've written omega. Omega is 4 by root 3 LC. Cos omega t. Remember, what is the maximum value of dq by dt? I max is equal to 9 CV naught by 4 times 4 by 3 LC. What else I have written apart from this? Same thing I have written. Same thing I have written. I max. So please try to understand. This is what I have written. Exactly. ఇప్పుడు ప్రతిసారి ఇంత చేయలేరు కదా మీరు. See, according to me, if you accept, according to me, all this below this boundary is a nonsense. You don't require. If you agree with me, that is the problem. That is the end of the problem. So whenever you face this problem, what to do? You need to do only two things. One, identify condition for common potential. So you got the potential. Identify the maximum charge transferred. You have done that. So maximum current is omega times maximum charge transferred. Okay, this is the concept I have introduced now. Right. So only till this point, I would like to take the class. Morning, it is not possible for me. So I have done it right now. Okay. Any doubts? Please ask me now.